Hello, so I thought I will make this video for you just so that I can tell you how to prepare for your final exam. Your final exam is comprehensive. It's about 2 hours. It's in the same mode as you had before, which is the Responders Lockdown Browser. The comprehensive part, of course, means that it is comprehensive, starting from chapter 6 all the way to what we did with 19, electrochemistry. So everything is going to be on it. So I just thought I'll go through with you and do how to prepare for the final exam and give you some other things also that I'm doing for the class. So first of all, let's talk about the preparation, okay, that you will have for the final. So starting from chapter 6, all right, which was thermochemistry that you did. One of the things that you will realize as you're going through all the material is that a lot of this material is kind of disconnected. Some of it is connected, but some of it is disconnected. So for example, in chapter 6, when you learned about thermochemistry and like specific heat, we never dealt with it again, okay, after chapter 6. So, depending on how your comfort level is with some of the topics as we're going through, you decide what you want to do, okay? So this is not the time to learn anything new. That's really what I'm trying to say, is if you understand things, that's great, you focus on your strength. But if you feel like, that this topic, I didn't really quite get it, well, this is not the time, okay, to try to learn it. So if you got specific heat, great, okay, that's great. But if you think that you did not get specific heat, all right, then don't do it, all right? This is not the time to learn it, unless you can, that's a different thing, all right? But otherwise, don't worry about it. The maximum I can do is put 2 questions on it, okay? So you should be ready to sacrifice 2 questions, which is maybe about 6 points, okay, for your exam. So don't sacrifice everything as you're preparing for your exam, otherwise you'll sacrifice everything, all right? So let's not do that. Let's try and focus on, learning everything. That's the whole goal, because as you're going forward to your organic chemistry and maybe biochemistry in future, you're going to need some of these topics, okay? And so you might as well learn it. That's the whole goal of taking a class. So in any case, from chapter 6, and here are my topics written down here. So in chapter 6, you had thermochemistry. In thermochemistry, you learned about specific heat, how to calculate specific heat, how to do thermochemical equation, Hess's law, delta H formation. So if you are good with all of these things, great, okay, then keep carrying on with it. If you think you did not get Hess's law, you have my permission to forget it, okay, it's all right. But then you also have to remember that you will lose 3 points, okay, in there. So you have to work extra hard for the other stuff. Okay, so then it was the states of matter. In states of matter, you learned about intermolecular forces, and you learned about the physical properties of substances like surface tension and all of that. I cannot emphasize to you how important all that stuff is, okay? So I would advise you to not skip it, okay? So intermolecular forces is something that you will encounter later on in organic, in biochemistry, and everything, okay? And in general, it explains all sorts of properties that you have for substances, so you should master that, okay? The thing that you may not need to master from that chapter is probably like phase diagrams, which is very easy. It's not that hard, okay? But in any case, so phase diagrams you can skip if you want to, although it is easy. So if you want a refresher, go ahead and listen to the PowerPoint lecture and see if you get it. But phase diagrams we never encountered again, okay? But intermolecular forces, trust me, okay, you will need them. So try to learn the intermolecular forces in there. Now remember, we did not do crystal structure, okay? So do not waste your time. Do not go over crystal structure for that. All right, so that was states of matter. If I'm forgetting some topic, then you can always ask me later, okay, like in an email. So then for solutions, okay, in the solutions, of course, you have to know how to calculate all the concentrations. Molality is linked to freezing point depression, boiling point elevation, so you can't skip molality, okay? Molarity is something you learned in Gen Chem 1 and you did it again here, and molarity you've been using later on also in all the concentration calculations, so you can't escape it, all right? Mole fraction you need to know, so that you can calculate the freezing point depression and boiling point elevation. So all of these things are connected, so please learn them, okay, and do the calculations. Go through all the worksheets that I have for you on the website, download them again, do them again. The solved problems are there too, okay, the key is there, so try it all out and see how you do in those. The only thing that may give you trouble in that chapter is towards the end when we get to Van 't Hoff factor, okay? Because I didn't go over Van 't Hoff factor too much in the PowerPoint either, and I don't give too many questions on it. So if that's something that you want to skip, again, you got my blessing. You can skip it, all right? But again, you might have one question it, but I give you extra credit stuff, all right? So in any case, so other than that, you should know how to calculate concentrations. You should know how to do Raoult's law, which is the boiling point elevation and freezing point depression, and then calculating molar mass, okay, from all of those things. So that was the solutions chapter. And kinetics, again, kinetics is something that you will need a lot. So you will need kinetics in organic as well as biochem, everything you need. This is a foundation course, all right? So kinetics you will need. So please learn how to calculate the order of reaction. Hopefully it's not that hard for you, okay? But otherwise go through the pencast, go through the PowerPoint lecture. So you have to know how to calculate the order of reaction. The other thing that we did about rates of reactions was how the concentration changes if you, with time, okay? So for 0 order, 1st order, 2nd order, all of these different orders of reaction. So look at how the concentration changes with time, okay? So you have the formulas, and remember, I'm going to give you the sheet for all the equations, okay, in there. So you have that then. So that was with kinetics. The only thing I did not emphasize too much on was the Arrhenius equation. The Arrhenius equation has to do with the speed of reaction at one temperature, then at another temperature, how that changes. So Arrhenius equation is something that I did not do much of, but again, I have the pencast on there. So if you want to go through it and see, it's not really that it's not that hard because it's formula based. Okay, so you just have to learn how to use the formula. So try that out. And then the mechanisms. I did not do too much mechanisms. Even in the PowerPoint lecture, you will see that the only two things I covered about the mechanism was the collision theory. This is how the mechanisms work, and the transition state. Transition state is that graph, okay, that you see. So those are the two things that we talked about as far as the mechanism is concerned. Regarding the step-by-step mechanism, skip it. It's not worth it, okay, at all. I don't cover it. I don't ask it, okay. So you will learn mechanisms when you get to other classes, but otherwise don't worry about it, okay. But then learn about the kinetics part of it, what I'm telling you, and that should be sufficient. And of course, what are the factors that affect rate of reaction: concentration, time, temperature, things like that. Catalyst, don't forget catalyst. All right, so that's all kinetics, and then we go to equilibrium. And you probably noticed as you were doing all of the studies for the last 2-3 weeks that equilibrium is something that we really kind of delve into, okay. So we started with equilibrium, and then for the next 2-3 chapters, that's all we've been doing, okay, is equilibrium. So you can see that this is not something that you can skip. It's also not a very large chapter, okay, it's a small chapter. So in equilibrium, you started learning how to do the change of concentrations, which is the ICE method, okay. So this is the initial concentration, change in concentration, and then you do the equilibrium concentrations. So then you set up your your Kc, okay, from there. So in some cases the Kc is easy to calculate. In some cases for the Kc you will have to use the quadratic equation, all right. And I'll give you the quadratic equation also in the list of formulas. So you have to see how to do that, okay. And please do not think that just because in acids and bases you were subtracting, you were ignoring the x, you cannot ignore x here, okay. So for all the equilibrium problems that you'll be working in here, you have to use the x, okay. So you are calculating for x, you are trying to find that equilibrium concentration, so make sure you do that well, okay, and learn how to use your calculator well so that you don't have any issues with that. So in equilibrium, you have to do the ICE method to figure out the concentrations, and then you also have to be able to do Le Chatelier's principle, okay. That is one of the key things, one key factor in there. And I hope you notice that later on as we've been working, we have been dealing with Le Chatelier's principle one way or another. That's called the common ion effect, sort of, okay. And so master the Le Chatelier's principle, which I think it's not that hard, okay, because it's just a shift in equilibrium, all right. So please do that. So those are the two main things that we did, okay, in equilibrium. So make sure you go through that. And then acids and bases. There is nothing I can say about acids and bases except do it, okay. That is like one of the most important chapters that you will encounter. You're probably thinking I'm saying that for everything, okay, but that's not true, okay. Acid bases really is the key chapter for everything. For understanding all the physical processes, you really have to know acids and bases, okay. So learn about how to classify acids and bases, learn how to calculate the pH. That's what we did in that chapter. And most importantly, learn how to figure out whether you have a strong acid or a weak acid. Follow my PowerPoint. Okay, so in the PowerPoint, I've explained to you how to determine whether you have a strong acid or a weak one. The textbook does a job, but it's not the greatest. Okay, so in my PowerPoint, you will find a little bit better criteria, okay, on how to solve for that, okay, because it's conceptual, it's not calculation. Okay, to figure out if you have a strong acid or a base, you do pH calculations. That's a different thing. Okay, so but conceptually you should be able to tell whether sulfuric acid is stronger or sulfurous acid is stronger. Okay, and so for those criteria, go to the PowerPoint, look at that, and there are about 3 or 4 criteria that you use. Okay, so that's the most important thing there. Lewis acids and bases are also important. Okay, but again, you might see that we didn't really use Lewis acids and bases. Okay, it's a very small portion of that chapter, so if that was a thorn in your bag, then go ahead and remove that thorn. No need to have that thorn, okay, in there. I might have one question in there, but again, if you master everything else in there, like the acids and bases, then it's okay. All right, you don't have to know Lewis acids and bases. You will learn it later on. Okay, so they are an important part. I'm not going to say they're not important. Okay, they are important, but at this level, you don't really get the concept so much as you will later on. Okay, so it's all fine. Okay, and then we get to acid-base equilibrium. In acid-base equilibrium, you saw that we covered the entire chapter. Okay, there was not a single thing that I left out, okay, in there. So everything is there. How to calculate the pH of a weak acid, of a weak base, okay, how to do that. How to calculate the pH of a diprotic acid, you did that also. How to do the common ion effect. So if you have something like acetic acid, you put a little sodium acetate, what does it do to the pH, okay, of the solution? So all of that we did, okay, and then we went on to buffers, which is kind of like common ion, okay, and so we went on to buffers, and buffers, of course, you don't change the pH, you know, by adding a little acid or base, so you have to know how to calculate for buffer calculations, so pH of buffers. And then, of course, the titrations come in, okay, with the titrations, you have the strong acid-base titration, and then you have the weak acid, weak base titrations and all of that. So those come in. With the buffers, you have to be able to calculate the pH if you add a little acid or a base. And I have a lot of pen cast for you for that. So if you think that this was something that you did not understand, go through it again and see if you can catch up. All right, again, do not try to learn anything new at this point. It's not worth it. Okay, so whatever you understood well already, focus on that. Okay, focus on that strength and then go on. Okay, so then we did the acid-base titrations, calculating pH. Calculating the pH, for example, for a weak acid, if you add a little bit base, maybe half the amount, and then at equivalence point. Okay, those are the 3 main things that we do in there. So one of the important things from the previous chapter, acid-base chapter, and this chapter, is for you to be able to figure out the salts, okay, that you form. So acid plus base gives you salt and water. So what is that salt? Is that an acidic salt or is that a basic salt? Okay, so you have to know what kind of a salt that is. All right, and that kind of a salt will help you determine how to calculate the pH of that. So once you know that you have an acidic salt, then you know you'll be calculating the pH. Once you know you have a basic salt, you know you're calculating pOH. So if you're asked a pH question, then you got to do one more calculation. You have to subtract the pOH from 14 to get the pH of a basic salt. So you have to watch out for those little things because that's really what gets us. Okay, it's not that we don't know how to calculate pH. We know how to do that. Okay, it's just that we forget that, okay, we need to subtract from 14, or we forget that the salt we are dealing with is a basic salt. So things like that is what we forget. Okay, so always pay attention to those little details, okay, that you're working on. You also have to remember, do I need to subtract something? Do I need to add something? So for example, if you're doing an acid-base titration, and if you're adding a base to an acid, when a base is smaller amount than acid, you'll be subtracting the moles, okay, of the base from the acid. So that's kind of what you have to do. So again, little things, okay? You got to pay attention to those. So that's acid-base equilibria. Again, we did everything, okay, in there. So make sure you do all of that, okay? And then after that, we get to solubility equilibrium. And I told you, I think we did only 4 or 5 sections from there. Don't do anything more than that. You just need that much, okay, in there. So calculating KSP, calculating molar solubility from there, doing the common ion, okay? And the common ion was, of course, if you had a solution of sodium iodide, for example, and then you add a little bit of silver iodide, what's going to happen? Will the silver iodide dissolve more or less? So conceptually you can do that too, okay, but then you can also do calculations to figure out by what degree is the solubility greater or less, okay, and in common ions generally the solubility is less, okay, and so that is there. And then of course precipitation. How do you predict precipitation? Precipitation is more like calculating QSP, okay, which you do QC back in equilibrium, where is the equilibrium shifting towards the left or the right. So you calculate the QSP for solubility also then. So this is a little bit of an involved calculation, okay, it's not hard, it's just a little involved because you got to calculate the moles of both, subtract the moles, you know, or excuse me, you find the moles of both, calculate the new concentration with the total volume, and then you figure out your QSP from there, okay, and so that's what you need to know. And then finally the last thing in solubility is how does acid or base affect the solubility of any kind of a salt, okay. Again, the salt becomes really important, okay. So back from acids, bases and all of that, we were talking about salts. It's really important for you to understand, okay, whether the salt is acidic or basic, because it will help you with the solubility also. All right, so that is up to solubility equilibrium. Now for the last two chapters here, thermodynamics, we did very little of it, okay, and so the calculation part of this is actually quite simple, all right. So the concepts that I really want you to take away, okay, from the thermodynamic chapter is the concept of spontaneity, okay. What does it mean for a reaction to be spontaneous? All right, so focus on the worksheets that I've given on the website and do them again and see if you get those, okay, because that's really what I would like you to learn from that chapter. Is something spontaneous or not? Process, is it spontaneous or not? Okay, number one. Number two, is something going towards higher entropy or lower entropy? Okay, that's an important concept, which brings us to the three laws. Okay, so you should know the three laws of thermodynamics, 1, 2, 3. So please note those down, okay, from your textbook. So the third one is like the lamest, I think. The first one is the easiest one, law of conservation of energy. So in any case, go through those laws. Those are what I would like you to know. And then of course, the last concept that we learned in that chapter is free energy, okay, delta G. So the concept of free energy, and then we did the equation, which is delta G is equal to delta H minus T delta S, okay. And so that's the one, that's the equation that I will give to you. So you just have to be able to work it, okay, which means that you should be able to predict whether a reaction is going to be spontaneous or not, okay. And remember, delta G should be negative, okay, for a reaction to be spontaneous. So you should be able to predict that. You can calculate that also. And then there is the delta G standard, okay, which is the delta G, and then it comes with a little degree sign on the top, okay. And so the delta G standard, delta S standard, you should be able to calculate those also, which is kind of like the same thing you did back in thermochemistry for delta H, for enthalpy, okay. So if you have to calculate that, you take the enthalpy of the products, the total enthalpy of the products, and subtract that from the total enthalpy of the reactants, okay. So it's fairly easy to do, okay. So the calculation portion of the thermodynamics chapter is fairly easy, okay. It's the concepts that you should understand. So that's for thermodynamics. And then finally we have electrochemistry, okay. And I don't know how that is going for you right now. In my class that I'm teaching face-to-face, it's going okay, all right. And so we just finished balancing equations, all right. So you definitely must know how to figure out oxidation numbers, okay, of anything, because if you don't know oxidation number, then you don't know how to go from point A to point B, okay. And so you don't know whether something is oxidizing or reducing. So make sure you understand oxidation numbers. And the second thing you should do is, of course, balance equations, balance electrochemical equations by the way of, acidic or basic medium, okay. And so go to the pencast again and see that, okay, and solve it step by step. It's not that hard, just take it step by step as much as you can. So that is solving the or balancing electrochemical equations, all right. That's one thing you should know. And see how much you can do for galvanic cells. I want you to be able to at least understand what a cell is and be able to tell me what the anode is, what the cathode is, what is the reaction going on, okay. That is pretty much it, okay, as far as electrochemistry is concerned for us. There is so much more interesting stuff about electrochemistry, okay, and I really hate it that we are towards the end and I can't finish the chapter, because it's a very interesting, very practical chapter. But in any case, that's as far as I think we will get. Don't worry about calculating E cell. Try to understand what that means though, okay, what the voltage means there, okay, because that has to do with the spontaneity of any reaction, all right, or any electrochemical reaction. So electrochemistry is the basis actually for batteries and all of that, okay? And so the way the batteries work, now you don't really have to do anything for your battery, right? Once you put that in your watch, it's going, all right? On the other hand, in your cell phone, you have to keep charging it, right? So which means it's a non-spontaneous reaction at one point and spontaneous at another point. So how do you do all of those things? And that is the voltage, okay? And what makes lithium batteries good, okay? That's the whole point about this beautiful chapter, okay, that we have. So in any case, that is your review for your final exam, which is comprehensive, okay? And I'm sorry that we have to do it this way, but I want to make sure that you remember everything, okay, that in there. And again, please try to focus on your strength as much as possible, okay? So focus on what you know already and build upon it. Try not to learn anything new at this point, okay, that you did not understand. Let it go, okay? But only let go of small things, okay? And they're maximum 6 points or something like that, because that you can make up on extra credit, okay? But don't let go of too much. So I hope this was good. Don't tune off, because I have another video for you, okay, talking about some other stuff. So go to the other one also, because this one is kind of running long. I think you might be getting bored, okay? So I'm going to make another one for you. So all right, okay then. Good.